My name is Thomas Hofmann. I work in the BMW hydrogen vehicle project, and my task also are to find research and development projects. So where are the technological challenges we still have to solve? So if you are an innovator or you have smart ideas, you can also contact me. Maybe we can set up and create projects. And I'm also the BMW representative for the... So it's on the stick, on my USB stick. This one? Yeah. Connected again. I'm the BMW representative in the German Hydrogen Association or the Hydrogen Europe or the Hydrogen Council. So I'm also here, here USB. The short version on the top, okay. No problem. I want to focus today, but on the other side, for us, it is very, very important to bring this vehicle project in a big picture, in a context. So I do not, present you today about the vehicle, the facts and figures about the car. This project is a story. It's a story we want to contribute to the future emission-free mobility. The hydrogen electric vehicle, is an electric vehicle. The difference is hydrogen is the energy carrier compared to the battery electric cars. And I want to invite you to start my presentation with a short movie. February this year we launched this car. We want to go now with this pilot fleet around the world to get impressions from the market, from the potential customer. And you see a lot, I've already seen a lot of things in that movie. We enable a lot of technology, internal BMW, and we bring also this story in the Hofmann in Antwerpen. For us, it's the big picture. We need in Europe also green energy as an import energy, and the Netherlands could be the place where green hydrogen will come to Europe, and this car should offer the producers a further application for their green hydrogen. And we at BMW, we want to contribute to this hydrogen future energy system. And I want to start my presentation with this slide to bring you in my presentation, a credibility. We at BMW, we have set the 1.5 degree ambitions as our own target. So we are the first car manufacturer. We set this target, and we want to reach this target by using all available technologies and take all process steps into account. So from the car production to the use phase and recycling phase. And we assess also the fuel cell powertrain in this technological openness, future emission-free technology. And we see as a result there could be more answers to the future future electric cars than the battery as an energy storage system in the car. And this is one of my main messages for you today. We see the battery and the fuel cell electric powertrains, they should combine in synergy the best for the customer. We want to take all customers in the future zero emission mobility. And back to my slide now, sorry to say a lot of words about these. We at BMW, we do not only say we have this climate goal for our Geschäftsbericht, for our annual report. We do a lot of invests already, and we plan to do furthermore to reach this target for to reduce the footprint. And this Morgan Stanley index already give us the result. We at BMW, we nearly on track, and we far ahead from the other car manufacturers. I take some here. This could some car manufacturers from Stuttgart area or Chinese or from California. So we are at BMW, we are on track, and we are doing this very credible, our measurements to reduce the CO2 footprint and to reduce the raw materials usage. So let's come short view. Already my speaker before mentioned this. We see in the total final big picture that it is smart to have more solutions than the battery electric cars, because it will maybe not possible to supply all energy with electric power directly from the renewable sources. We think there would and storage element necessary, which could be hydrogen. Hydrogen is possible to transport energy for long distances, to store energy in a huge amount, and this indirect use of electric power, then hydrogen will exist, and in best case, and to reach a profitability for them, hydrogen should have a lot of applications. And we think it also should the mobility sector an application of hydrogen, because one of the answers is also in the next slide given. Of course, the mainstream here in green color for battery electric mobility, we think the passenger car fits perfect for battery electric mobility. However, the heavy duty sector will maybe need more solutions to reach the goals, and the fuel cell technology here in blue color, signed. It is smart to have maybe the fuel cell technology. Some points I want to highlight here. The heavy battery will reduce the load, the possible, and the charging time will reduce the driving time. So this is from the total cost of ownership. Very interesting to take also the fuel cell technology into account. And if this will happen also in perspective of infrastructure, etc., then it could be a very good niche also to offer this technology in the passenger sector. We then maybe can offer the supply chain, the economy of scales. The cars have more figures in sales, and so we can go hand in hand. It's like a team sport to enable more technology, to find in the big picture the optimum for all. So we at BMW, we think that would also be here a niche or a future niche for the fuel cell technology, and why we think these. You see here, this is the agenda, my personal agenda in the next slides. We think that it will a good solution to have the fuel cell in addition to battery, from the technology perspective, from customer perspective, for infrastructure, for an energy system, and from the raw materials. And after this, I want to invite you to have time for me to go inside the car. How will this technology work? So, from technology side, I mentioned it already on my first slide. We think both technologies will, in best case, have a lot of synergies together. We want to use the same electric engine in the car. And of course, in the next step, you see here the battery electric car, and here a schematic view from the fuel cell electric car. The hydrogen tanks currently looks like that. You have the hydrogen tank in the middle, and here it's like a T shape. And when we adapt the geometry of the hydrogen tank, that they could fit in the same space where the energy, the battery is integrated in the car, then we have a flexible in synergy car architecture, and the customer and the market can decide which technology they want to use and fits best to their requirements. And for us, then we have reached the step to be profitable. We use a lot of synergies together, and yeah, then can also offer this technology. And of course, then the same electric engine, the same car architecture I mentioned already. Yeah, and then you can imagine the synergies and the flexibility in the production line. From the customer perspective, only 4 highlights here are mentioned. Yeah, we think there will be customers also in future without convenient access to electric charging infrastructure. We think the customers love to be flexible and free like they are today, to have the fast refueling process possible. People love to do the same things at the same time. In Bavaria, the holidays are beginning, and we meet all of us on the Öschenberg highway station to make the refueling and to buy the pickle and to continue the ride to Italy. And when you take into account we all want to do this at the same time to refill the car with energy, then we have waiting time, etc. And time for us is very valuable, and especially I think for BMW customers, they want to have good solutions which offer them to be free and flexible, make a rest when you want to make a rest, and not because the car now needs a rest and the charging time. So that's some arguments why we believe we need more solutions than battery electric. And also in cold climate conditions, this powertrain is very robust, so you do not lose range in cold conditions. Or when you love to have trips with the towing, it's also a smart solution. Then you have the opportunity to have the fast refueling. Or when you take in the driving assistance systems, the automated driving, they have a lot of sensors and actors, need a lot of energy. And if the customer want to have these driving assistance systems running, you will need a lot of energy on board. And yeah, if you can refill this energy very fast, it's also very comfortable. From infrastructure perspective, also in green, there's a schematic view. What does it mean to offer for all cars in Germany electric charging infrastructure? These studies have analyzed these, and the answer is the last 20 or the last 30% will cost a lot of money, and the costs go up, and it sounds scary. Yeah, you do something more and more, build up charging infrastructure, and by the end it will cost more and more. Yeah, you need a thicker supply chain from the electric cable, etc. And if you mix 2 infrastructures in the system, the hydrogen refueling infrastructure in addition, then the analysis show it costs for the whole society less than to stand on one leg to build for all electric, for all mobility vehicles and charging infrastructure. And we have done the same analysis not only for Germany, we have done this also with the Hydrogen Europe, the Clean Hydrogen Partnership, the McKinsey guys have done this, analyzed. The figures are not so crucial at that moment, that the trend is the main message. So if we have a low scenario with hydrogen mobility in addition to only BEV infrastructure for all Europe vehicles, and is also here the message in Europe, and hydrogen in addition to battery electric mobility will reduce the costs in total for the system. And also in China we have done this analysis, so 2 infrastructures are cheaper than 1. Yeah, what is the situation nowadays? In Germany we have around 100 hydrogen refueling stations, in Italy 1. In America, focus nearly total to the California. And in China, a huge momentum and huge ramp up in hydrogen infrastructure. The government has also observed this technology and expected it's a race on technology here. Huge energy companies like Sinopec are willing to also set up hydrogen infrastructure to find out is this a future business model for them. And in South Korea and in Japan, a long history in hydrogen. They have a hydrogen society. They have already out with the Hyundai Nexo and the Toyota Mirai passenger car in the market. Okay, and you see this. You can ask BMW, why are not selling the car? The answer is also, it is not profitable from the car side. I mentioned the car architecture needs special adaptation from the floor to integrate the hydrogen tanks from the one side, but on the other side, the environment. We need an hydrogen infrastructure network which works out. So in Munich, we have only 3 hydrogen refueling stations. 5 years ago, we have 5. Now only we have 3, and this will not work for the customer. And our customer, the passenger customer, they love to drive to Italy or to Portugal, to Spain. So in complete Europe, take into account it's too less. And to solve this often mentioned chicken egg problem, we have in Europe an initiative, an alternative fuel infrastructure regulatory, which gives the stable framework. It's a regulatory, so it's a binding objectives, binding targets for the European countries to build up not only the charging infrastructure for battery electric cars, also they have the aim to build now a hydrogen infrastructure for hydrogen refueling stations. So it means on the main traffic routes in Europe, they have to build up at least each 200 kilometers on hydrogen refueling stations. And this will give a stable framework for the heavy-duty vehicle sectors, for the OEMs. Yes, hydrogen refueling stations will come, and then they can start now to build up the products to bring them in a commercial quality. Back to the BMW perspective, we did a tough assessment. Will this also good solution take into account the production, the use phase and the recycling phase? Yes, is the answer. We have similar results when we investigate here what is the footprint here in these phases, and BEV and fuel cell electric can both help to decarbonize, and they have nearly the same life cycle analysis in result. Bring it closer. The fuel cell electric vehicles need less raw materials and need also less critical raw materials. In a fuel cell, you need platinum, and here is an option. You can use secondary material from the combustion engine catalysator, and then it is like a circularity of these materials to use in that car. And this is very interesting also from this perspective to enable this technology. Where we are now, we have launched this pilot fleet. And we have shown here you can integrate these powertrain in a normal car. The technology is very performant. We have more than 400 horsepower on the road, and the technology is major. So we have done the summer testing in the south of France several times, the winter testing in Sweden, or the Alp testing, etc. So we have done everything which is necessary, crash tests, etc., to have here a series product. And we want in the next step to enable this technology in a commercial product. And then, some guys see analogies to the battery electric cars in the phases we are. First, BMW have done the pilot fleets, and then the first model with the E3. And the technology was enabled, and the market conditions developed very well. And then we have been able to bring several products in all BMW classes. And that could be the way we can go here in these phases, also. By the end, as I mentioned, it's an electric car with great acceleration, zero emission, and I'm very proud as a developer engineer. It's really a smooth and a silent ride. You have no difference between the battery electric car and yeah, with this asset, you have the fast refueling. How does the powertrain in the car look like? Under the hood, you have the fuel cell system. You can offer 125 kilowatt hour continuous performance from the full to the empty tank. Then you see the hydrogen tanks, approximately 6 kilogram hydrogen we have on board. Hydrogen is measured in kilogram. You can calculate around 1.2 kilogram per 100 kilometer driving. And in the back, you have a power battery, which can add power to the fuel cell performance up to 170 kilowatt. So in total, we can offer 295 kilowatt, which means 400 horsepower. This battery is not as an energy battery. It's a battery with very less energy. It is specified to offer power when the driver needs additional power. And it's not a battery for external charging. So this battery is for the system optimization. And the energy is very also important to understand. The energy is directly from the fuel cell supply to the engine. So the fuel cell system is a very dynamic system. One example, to offer from 0 to 90% performance in 0.4 seconds. So less milliseconds are only necessary to have the fuel cell acceleration. Okay, I go, Ari. So maybe interesting for you, one single fuel cell is a very thin plate, like a keyboard, a computer keyboard from the dimensions. On the one side, hydrogen is floating, here in blue, the molecule. The molecule divides from the catalysator divides. The electron goes away, it's the electric energy, and the proton walks through this mesh and marry on the other side with the oxygen here in red, and the byproduct is heat and water vapor. So it's an electric car where water vapor will coming out, and several hundreds of these single cells are in the fuel cell stack integrated, and that the fuel cell stack is here. The system needs also a recirculation booster, that hydrogen will come again and again to the fuel cell. You need a humidifier to optimize the process, to make the air from the environment a bit more humid. And this will operate here under the hood in the fuel cell system. So by the end, as I mentioned already, sorry for my time, this is the car with the facts and figures. You can read very fast. So already with this pilot fleet, we are very interesting regarding the vehicle weight or the acceleration. The maximum speed is given here because of the fuel cell power. Of course, you can drive more than 200 if you like. Then, however, you have the additional energy from the battery, and this is not for the whole time possible. And by the end, we think hydrogen will become a part of the future sustainable energy system. We think the hydrogen fuel cell technology can make a very valuable contribution to achieving the sustainable goals, meeting the customer needs, and diversify the dependencies. We have achieved a high level of self-empowerment with this pilot fleet, and now we want to meet now the customer and make an enthusiasm for this project, and go to also the next step. Thank you for your attention, and I have to say sorry for my extra time. Thank you.